Part B is on compaction of asphalt test specimen using the Gyratory Compactor. So we are doing our sample for medium and heavy traffic category. In part A, we prepared the aggregate mix of 1,140 grams, and we add 60 grams of bitumen and we mix it. Bitumen is a viscoelastic material, so at the room temperature it's a solid, so we have to heat the bitumen to 105 degrees Celsius to mix it with, make it a liquid and mix it with the aggregate. So after we are mixing this, our sample will look like this. And we use this sample for the part D to find the bulk density and part C to find the maximum density. As you see here, to find the bulk density, we need to have a cylindrical sample. So to get the cylindrical sample, we have to compact this sample in a machine. So in the part B, what we are going to do is we use the Gyratory Compactor to compact this material to get this cylindrical specimen. Gyratory Compactor is an electropneumatic machine designed to produce 100 millimeters and 150 millimeter diameter cylindrical asphalt specimens of specified density. In our class, we are using 100 millimeter diameter specimen. So we have a mold of 100 millimeter diameter, and we put our asphalt mix into this and we apply a vertical force. This vertical force is depending on which traffic category we are considering. So in our case, we are using 240 kilopascal of vertical pressure. And while we are applying the vertical pressure, the cylinder is rotating. So we have determined this is a predetermined angle. We keep this 2 degrees. And for our traffic category, we rotate this in 80 cycles. So this cylinder is rotating 80 cycles totally. And this, after we get the specimen, that specimen has close to the characteristic of the compacted pavement for this traffic category, for the wearing course. This is the machine that we are going to use. And as you see here, this is our the cylinder. So you can see this rod which is applying the vertical force. The cylinder is rotating and this with the set angle which is 2 degrees. And we set the pressure, and you can set the pressure here, and you can see that reading 240 kilopascals here. We can see the number of cycles in this window. When we apply a vertical force to a cylinder, what is happening is it's compacting. So you can see this height of the cylinder is reduced with the number of cycles. So you can read the height of the cylinder with the number of cycles here. So you can see the number of cycles at the top, and you can see the height of the cylindrical specimen at the bottom. So these readings we will take down, and we have a table to fill. So as I told you, we have to select the right number of cycles for this compaction. We are using 80 cycles as our traffic categories medium to high. And these are the variables that we have set in the machine. So we are using 80 cycles. Vertical force or the vertical pressure is 240 kilopascals. The angle of the gyration is 2 degrees. And normally the height is 65. Anyway, we are going to measure this one. The specimen diameter is 100 millimeters. So this is the table that you need to fill for the part B. As I told you, while the compaction happening, we read the number of cycles and the relevant specimen height. So we are doing for 5%. So you can get this reading from the machine when it is compacting. And as I told you, the sample is heated to 105 degrees Celsius. And after doing the compaction, we get the sample out and we can measure the weight, and we can get the weight as well. With these measurements, you can find the density of the sample. So density is the mass divided by the volume. The mass we are measuring here And the volume is depending, this is cylindrical sample, so volume is the area and the height. So this height is changing with the number of cycles, so your density will be different values, and you need to do the calculations and find the density for different number of cycles. So you have this equation here, you can use it and you can do the calculations and fill the table for all three bitumen contents. Bitumen is a viscoelastic material, so we can't mix bitumen and aggregates in the room temperature. So we have to heat the mix. So we have the oven and the temperature is set to 105 here. And you can see our mix now. It's heated and it's in the oven. Next to that material, you can see the heated cylinder that we are going to use for the compaction. And this is the mixture that we are going to use to mix the asphalt and aggregates together. Okay, after mixing, we'll compress it in the compactor. So you can see here the cylinder that we are going to use for the compaction. It's also heated in 105 degrees Celsius. Now that's the mixture which is heated and well mixed. So underneath this cylinder we are using this plot paper. We have the dimensions. This is a standard test and we have the dimensions of the cylinder, and we are using about 1,200 grams of the sample which we have just prepared. The diameter of the cylinder is 110 millimeters. The nominal height is 65, and the angle, the machine, we have set the angle to 2 degrees. And we are designing for medium and heavy traffic. So the vertical load, to simulate the medium and heavy traffic, we have set the machine to a vertical loading of 240 kilopascals. Now we'll see the compaction in the gravimetric compactor. So while compacting, we have to fill a table. So that table is the B1, and in each of these cycles we have to measure the the height of the cylinder, and when it's going to tell us the height of the cylinder, now you can see the machine is operating and the sample is compacting. So at 20 cycles, 69.2 millimeters the height.
67.6.
67.6.
67.3.
So next reading is at 60 cycles. You can see the cycle number here.
67.2.
So the height is 67.2 millimeters. The next cycle is 80. So we are only doing up to 80. So when the cycle number is 80, we take the reading here, the height.
66.9.
66.9. And in this machine you can see this is where we set the vertical load. So we have set it to 240 kilopascals. And after finishing this, we can take the cylinder out and we can use that specimen for the other tests. And the test sample is heated to 105 degrees, so you can write down that in the table. And the sample mass, we are going to measure it after we'll take the cylinder out. Okay, now this is the sample which we took from the compactor, and we can take the sample out from the cylinder now. So this is our cylindrical specimen. It's still hot, and you need to write the weight of this one. So the weight of this one is, so we'll measure the weight. So it was set to 0. The weight of the sample is 1113.9. So that's for the part B.